we see our planet from the perspective of space, certain things become undeniably clear. We keep trying to deal with issues such as global warming, deforestation, biodiversity loss as standalone issues, when in reality, they're just symptoms of the underlying root problem. And the problem is that we don't see ourselves as planetary. When I looked out the window of the International Space Station, I saw the paparazzi-like flashes of lightning storms. I saw dancing curtains of auroras that seemed so close it was as if we could reach out and touch them. And I saw the unbelievable thinness of our planet's atmosphere. In that moment, I was hit with the sobering realization that that paper-thin layer keeps every living thing on our planet alive. I saw an iridescent biosphere teeming with life. I didn't see the economy. But since our human-made systems treat everything, including the very life support systems of our planet, as the wholly owned subsidiary of the global economy, it's obvious from the vantage point of space that we're living a lie. We need to move from thinking economy, society, planet to planet, society, economy. That's when we're going to continue our evolutionary process. I'm Ron Garan. I'm a former NASA astronaut and former combat fighter pilot and the author of Floating in Darkness, A Journey of Evolution. We are all, as a species, to some extent, floating in darkness. And I use Plato's allegory of the cave to illustrate how a lot of times we think we know the whole picture, when in reality we see a very, very small representation. We don't see the actual picture that will allow us to solve a lot of the problems that we face. And we're paying a really high price right now as a civilization. This is a really, really dark time. And part of the reason why we're not solving the problems is because we don't have the right perspective. We're not addressing things in the reality of the situation that they exist. And I think that's one of the reasons why we need to leave the cave. We need to get out of the darkness. A lot of astronauts who go to space come back and they feel that there has been some sort of transformation. And a term was coined back in the 80s called the overview effect. And the overview effect describes the shift that astronauts have when they see the planet hanging in the blackness of space. There's this light bulb that pops up where they realize how interconnected and interdependent we all are. A little over 50 years ago, humanity as a whole had a collective out-of-body experience. On Christmas Eve, 1968, the crew of Apollo 8 came out from behind the far side of the moon on their fourth orbit. They took a famous color photograph, and that photo is called Earthrise. Earthrise is the first color photograph to see the whole planet hanging in the blackness of space, and the first to capture that for the rest of us. And this image revolutionized how we see the world, how we see ourselves. There is no such thing as them. There's only us. And precisely 1 year before the Apollo 8 astronauts were hurtling through space on their journey to the moon, Dr. Martin Luther King Jr. gave a Christmas sermon on peace. And I believe that that sermon really gives words to what Earthrise evoked. Dr. King said,
"As nations and individuals, we are interdependent.
We're not going to have peace on Earth until we recognize the basic fact of the interrelated structure of all reality." Now, the interrelated structure of all reality, that's not a cliche, that's not a philosophy, that's the reality of the world that we live in. That's fact. That what happens to one directly affects all of us indirectly, that we are all inextricably linked together in this fabric of life that we call Earth. So if the overview effect is that light bulb that pops on, is the awareness of our interconnected, interdependent nature, the orbital perspective, which is the title of my first book, is what you do with that awareness. The orbital perspective is the call to action. It's a sense of injustice that we see when we see the sobering contradiction between the indescribable beauty of our planet and the unfortunate realities of life on our planet for a significant number of the inhabitants. One of the things that I realized during my time in space is that we're not from Earth, we're of Earth. And to take that one step further, is that we're not in the universe, we are the universe. We are the universe becoming conscious of itself. A lot of what we're talking about doesn't require going to space to realize. You don't have to be in orbit to have the orbital perspective. And one of the tools that we can use is a term that I borrowed from cinematography called a dolly zoom. And what a dolly zoom is where the camera is rolled back or dollied back at the same rate as the lens is zoomed in. And it was used in Jaws and Vertigo and many other films. And what the filmmakers use that technique for is to give altitude to a scene as the foreground stays the same and the background stretches. But we could also apply that term to the challenges that we face. If we dolly zoom a situation, that means that we zoom out to the widest geographical area we possibly can, ideally the entire planet. But as we zoom out to that big picture, we don't lose focus on the worm's eye details on the ground. We don't zoom out to the point where people become numbers on a spreadsheet or a workforce or a voting block or a consumer block. They maintain their value as valued members of our human society. There's also a temporal aspect to this. We need to zoom out to the longest time frame possible, ideally multi-generational, but in the process, we can't lose sight of the short term. The last part of a dolly zoom is to see things from different perspectives. And so we understand the depth of our problem, and that makes our solutions that much more lasting and that much more effective. You have an incredibly powerful position to affect real change in the world. What I try and do is to live a constant dolly zoomed life. I wake up every morning in my bed, but I also wake up on a planet. In the long term, I'm very optimistic because I do see quite clearly a blossoming unity spreading across our planet, a blossoming awareness of our interdependent nature. That awareness will eventually reach critical mass, and when it reaches critical mass, then we'll be able to solve the problems facing our planet.
That is the GOES X-ray flux. I'm going to make myself a little bigger because I'm pretty and nice to look at. Let's also actually make it like this because we're not going to need that. And plus, I would like you to be able to see my wonderful stuff in the background. GOES X-ray flux, what you're looking at, that's an X-class solar flare. Let's come up to the 6-hour run. Not exactly an impulsive spike, is it? Point up and down. Well, it has to go for much longer in order to be classified as a long duration flare. You can just look at the angle. That's not coming out of the X-class range for minutes. How long is it going to take for that to come down out of the M-class range? That's a long duration solar flare, and it's right around the peak of that when you actually get the release. So let's go ahead and actually watch this. Coming from right there. Coronal clearing couldn't be more obvious that literally the entire coronal plasma population above and in the surrounding area above that sunspot, basically in this entire curl leading into and around the coronal hole, all the plasma in the corona above that blasted away just now. You can tell. Watch. It's going to happen again in moments. I don't have the timer up there because I'm zoomed in close enough so we can see it closely. Here it comes. Blatantly obvious, the entire push directly out. Yes, this is from Earth orbiting satellites, which means we've got an Earth-directed CME coming from that. Would you like to watch this in any other wavelengths with me? I think that could be fun. What do you think? Whoop. 94 angstroms, showing mostly the X-rays of the solar flare itself. Bright. That bright flash was bigger than, so let me go back to that right there. That is an explosion of X-rays. Bigger than Jupiter. Imagine an X-ray explosion bigger than the entire planet of Jupiter. You know what? Give me a second, actually. This could be fun. Hold on. Yeah. Let's make us feel about as small as humanly possible right now. This is going to be fun. 94 angstroms. Oh, are you not caught up yet? All right, let's go to GOES then. We can work with that. If GOES is updated. Sí o no? Sí. Claro. This is the size of the Earth. Okay. Let's check this out in another angstrom. How about 171? Actually, 195. Wow. Well, having said that and having looked at that, might as well do this one too, shall we? Let me zoom ahead here so we don't have to watch the whole thing play out. All right, here it comes. Here's what I can't tell. Do you see this? Let's kind of zoom in further. You guys see this? This like rope, this continuous rope of plasma right there. That's a lot of mass. That's probably more mass right there than the entire coronal plasma up above it that erupted. Literally, that little rope right there. And I can't tell if that just broke out like this or if that erupted upward. As I'm kicking stuff over here. And as I'm looking at what I'm kicking, I missed. We're not going to be salty. We're not going to be salty. The sun's salty. I can't be salty too. Can you tell if the filament lifted or broke open? We're looking at the rope right here. This thing right there. It matters.
NOAA has updated their forecast for the solar storm coming to Earth from the X2 solar flare and CME eruption yesterday. They forecast the same direct impact, but have an extremely different take than NASA's Enlil forecast. Tomorrow night impact? Nope, try in the next few hours. They're forecasting G4 storms, nothing to sneeze at, but will still require the south-pointing magnetism in the solar wind to reach that level of disruption. The bad news is that if it has it, it's going to be combined with the coronal whole stream density shock, and the electrodynamics could get wonky. We're not talking kill shot, but electrical, digital, and network issues for sure. Most importantly, however, low latitude auroral potential. If it's clear tonight, we have a great shot at seeing the lights. I'll be updating the data on my X account @SunWeatherman, so if you want real-time updates when it hits, be there. Have a good evening. Fingers crossed for a show from the heavens.
Throughout the universe, there are forces fundamental to how things move. Just as gravity is key to how things move on Earth, a process called magnetic reconnection is key to how charged particles speed through space. The more we understand how those particles are accelerated, the better we can protect our spacecraft and astronauts as we explore deeper into the solar system. And now, NASA's Magnetospheric Multiscale Spacecraft, or MMS, has discovered magnetic reconnection occurring in a new and surprising way near Earth. Typically, images of our planet from space show a blue-green sphere engulfed by the darkness of space. But invisible to the eye, a vast network of magnetic energy and particles surround our planet. Earth's magnetic field creates a protective bubble that shields us from highly energetic particles that stream in both from the sun and interstellar space. As the solar wind bathes our planet, Earth's magnetic field lines absorbs this energy and gets stretched. And like elastic bands, they eventually release energy by snapping. As a result, particles in the region are flying at supersonic speeds. That burst of energy is magnetic reconnection. It's pervasive in the universe. It happens on the Sun, around Earth, and flings particles across the solar system. Scientists have observed this phenomenon many times in the magnetosphere, Earth's vast magnetic environment. Now, in a new study, MMS caught the process occurring in a new region. For the first time, magnetic reconnection was detected in the turbulent magnetosheath, the boundary between the magnetosphere and solar wind. This region is made up of turbulent plasma. It's one of the most chaotic regions in the near-Earth space. MMS captured 3D observations by flying 4 identical spacecraft in a tight pyramid formation through the magnetosheath. These arrows show the hundreds of observations MMS took to measure the changes in particles and the magnetic field. This is the moment MMS sees bursts of energy from magnetic reconnection. But these signatures don't look like standard reconnection. Compared to standard reconnection that occurs over tens of thousands of miles, this new magnetic reconnection spans only a couple of miles within turbulent plasma. These reactions are essentially much smaller but more stretchy elastic bands that accelerate particles 40 times faster. In short, MMS spotted a completely new magnetic mechanism that's much quicker than we've seen before. Just like when you mix milk into coffee, turbulent plasma in space moves randomly and creates vortices. It can transport particles and energy, but a lot is unknown about how these particles move through these regions. Showing that this new magnetic reconnection plays a role in turbulent plasma gives scientists insights into how turbulence influences particles moving through space. By looking at such fundamental processes in space at both large and small scales, scientists can learn what drives the complex environments we travel through to explore our solar system and beyond.
Hidden Magnetic Portals Around Earth, presented by Science at NASA. A favorite theme of science fiction is the portal, an extraordinary opening in space or time that connects travelers to distant realms. A good portal is a shortcut, a guide, a door into the unknown, if only they actually existed. It turns out that they do, sort of. And a NASA-funded researcher at the University of Iowa has figured out how to find them. We call them X-points, or electron diffusion regions, explains plasma physicist Jack Scudder of the University of Iowa. They're places where the magnetic field of Earth connects to the magnetic field of the Sun, creating an uninterrupted path leading from our own planet to the Sun's atmosphere 93 million miles away. Observations by NASA's Themis spacecraft and Europe's cluster probes suggest that these magnetic portals open and close dozens of times each day. They're typically located a few tens of thousands of kilometers from Earth, where the geomagnetic field meets the onrushing solar wind. Most portals are small and short-lived. Others are yawning, vast, and sustained. Energetic particles can flow through the openings, heating Earth's upper atmosphere, sparking geomagnetic storms, and igniting bright polar auroras. NASA is planning a mission called MMS, short for Magnetospheric Multiscale Mission, due to launch in 2014 to study the phenomenon. Bristling with energetic particle detectors and magnetic sensors, the 4 spacecraft of MMS will spread out in Earth's magnetosphere and surround the portals to observe how they work. Just one problem: finding them. Magnetic portals are invisible, unstable, and elusive. They open and close without warning, and there are no signposts to guide us in, notes Scudder. Actually, there are signposts, and Scudder has found them. Portals form via the process of magnetic reconnection. Mingling lines of magnetic force from the Sun and Earth crisscross and join to create the openings. X-points are where the crisscross takes place. The sudden joining of magnetic fields can propel jets of charged particles from the X-point, creating an electron diffusion region. To learn how to pinpoint these events, Scudder looked at data from a space probe that orbited Earth more than 10 years ago. In the late 1990s, NASA's polar spacecraft spent years in Earth's magnetosphere, explains Scudder, and it encountered many X-points during its mission. Because Polar carried sensors similar to those of MMS, Scudder decided to see how an X-point looked to Polar. Using Polar data, we have found 5 simple combinations of magnetic field and energetic particle measurements that tell us when we've come across an X-point or an electron diffusion region. A single spacecraft, properly instrumented, can make these measurements. This means that a single member of the MMS constellation using the diagnostics can find a portal and alert other members of the constellation. Mission planners long thought that MMS might have to spend a year or so learning to find portals before it could study them. Scudder's work shortcuts the process, allowing MMS to get to work without delay. It's a shortcut worthy of the best portals of fiction, only this time the portals are real. And with the new signposts, we know how to find them. For a portal to more NASA science news, visit science.nasa.gov.